My session is splendid because I cannot prepare for it. This means I can just come here and do my thing and you will be either happy or not. We will design a platform as a service application on the fly. I have a few slides about the basics of platform as a service applications. And then I will ask you guys what kind of an application we will design. And I will wait until you answer. And the wait will be uncomfortable. Even more to you than to me. I'm happy being silent. I'm the silent type. Thank you. So, Sakari, Nahi, what I wanted to highlight is Ikkuna Studio, a Microsoft thing, a podcast that we've been doing with Jouni Heikkinen for 6 years. There might be every now and then episode that is interesting, so check that out. Otherwise, no new stuff there. And Azure, we build stuff. This slide I added because we opened office in Denmark this year, so I wanted to say that out loud. To platform as a service. I said that Magnus has said the cloud is commonly mistaken for being primarily a technical challenge. It is in fact primarily a strategic business challenge with a human capital challenge. Now I heard Magnus say this, it's been quite a long time. And in this talk we will focus on none of that. Instead, we will focus purely on the technical challenge, which is, let's face it, the more interesting one anyway. I'm not saying that everything is possible to do in the cloud with platform as a service, but I'm saying it is possible to do with platform as a service. There still are things you shouldn't attempt to do with platform as a service. You do not get full control on all of the resources you use. In some cases, if you have a factory running in Rovaniemi and you need to control the production line of that factory, maybe it doesn't make sense to have the controls for that in Amsterdam. So there are some cases, but unlike 5-6 years ago when it was common for us who were doing this then to say to client, this is not a case I would build on cloud right now. It's a different world. It's very rarely a business case or business need cannot be met with platform as a service components. Why would you look at platform as a service components when you have perfectly good cables in your cupboard? There are some reasons. Infrastructure as a service is something people are very familiar with. We know how that works, and that's an advantage. You get a lot of control, that's an advantage. But you also get a lot of administration work. There's slow time to live, you need to wait for stuff, or you need to configure stuff. It's hard to scale. If you have virtual machines and you run out of that virtual machine, you need to scale with another virtual machine and so forth. But it is existing knowledge. And then platform as a service at the other end, on that side, you have less control to those resources that are provided by platform. But that also means you don't need to look after them as much. So less to administer. Therefore, you get fastest results if you are trying to build an application or a solution. You just set up some PaaS service, you configure it less than you would if the other option would be to install a virtual machine. And it's easy to scale because Microsoft has all of these mechanisms that let these resources scale with usage. And of course, they bill for that. So it's nice they have the mechanism for them as well. But it's new knowledge, and we had 2 talks where it's clear that this new knowledge bit can be demanding and requires the support of the leadership team of that company. In between, there's containerization as a service. Best of both worlds, one could say, except that Kubernetes is so goddamn hard that I'm not sure if it's the best every time. But with those kind of things, with Docker and Kubernetes, you get more control than with platform as a service, but you get more stuff to configure. and it's also new knowledge. It's not like if a team goes to a project and they do a cube project, it's not guaranteed to succeed, right? We all know that. So we are gonna err on the side of platform as a service in this talk. And at the end of this talk, my promise is that you've seen a person who's done this for 10 years now to Azure. Do it. Like, I don't know if you agree with me. It might be a huge fail, and that's what we are hoping. That would be entertaining. Or it can be a success, and then you maybe learn, okay, this is the way Sakari looks at those things. This is an example of where we could end up being. We are coming to a diagram like this. This is something we built for Seure. They have this mobile application for 15,000 workers who every weekend or week or whatever look for jobs or gigs, as they call them. So here, worker is searching for Helsinki Päiväkoti. So that's early childhood education professional view. And here's the architecture. You see there's the source systems down below, there's the ERP system, data, Snowflake, some robots. We get that data to storage. We do some stuff with the data with Databricks and Data Factory. Then we push that data to clients, to mobile and web applications via API management from APIs, concrete API implementations. And there we have eventing or messaging of some kind, so we can have serverless workers working on some specific processes. That's the amount of boxes or things we will see. On the topic of amount of boxes, if you go to azurecharts.com, you can check what's the state of Azure from someone's viewpoint. And there are quite interesting features on that site, including this heat map of what services have been updated lately by Microsoft. And that's interesting since every now and then, some services on Azure are sunset. Microsoft decides that, okay, this data lake version 1 is very bad. We're going to have to sunset this. This will be obsolete. We're going to have data lake generation 2, which will be superior. And those kind of things might sometimes be possible to predict by going to Azure Charts and seeing if the resource or service you are thinking of using is receiving updates often enough. So when you start the next greenfield project, you start building something, go there with the team. See if the pieces you are looking at, if they are so mature that they don't need updates, or if they're so shit that nobody's updating them because Microsoft is thinking of replacing them. There's plenty of services. Now in this talk, yeah, white boxes came up. In this talk, we will be looking at mostly these areas. When I ask you soon, in a few minutes, I'm going to ask you for an idea to design. If you have some kind of an IoT sensor idea, or if you have a data warehousing idea, then these boxes are wrong. Then we will use other services. But if we are looking at custom application development with a front end on mobile or web, these are the things that we will look at. And now when you look at this, it's not that scary. You've done Azure or you haven't done that Azure, there's just 10 boxes you need to know a little bit more about, and you can go forward with creating the base architectural thinking of the solution. A few words on this. First is running the code, the compute on platform as a service. So your people, they develop something, and then all of that code goes somewhere in a packaged in some manner to Azure, and App Service and Azure Functions are the two most common services used. The difference being, of course, that App Service you pay for a monthly price for a certain size of a machine, so their infrastructure is quite close. You decide how much memory it has and so forth, and then you have your payload running there all the time. And then Azure Functions are serverless components that are triggered by a request or by a timer, it's 12 o'clock, let's do this integration or whatever. So these are the two normal choices. And usually, if you are doing an API that is supposed to respond to the queries from a mobile app services are the go-to tool, because we cannot guarantee if your Azure function is on a consumption plan. We cannot guarantee it wakes up in time so that our user doesn't get frustrated. Now these two are getting a brother. They are getting a friend that was generally released and became generally available in build now, Azure Container Apps, which is kind of like managed Kubernetes, but since there's managed Kubernetes service called Azure Kubernetes Service, then Azure Container Apps is something that's closer to platform as a service, but you still use Docker or containers as your packaging mechanism for your code. And then you can use Azure Container Apps where you push your containers. You can use that to define ingress and domains. And you can use KEDA, and you can use Tapper, and you can use all kinds of things. So Azure Container Apps, if you're not that familiar with that yet, then why would you be? It just became generally available. I'm not that familiar with it. But it's somewhere between these two guys and Azure Kubernetes Service in the middle. You're still working with containers, that's how you package your code, but you don't need to configure the running as much. So quite excited about that one personally. Once you have your code running, you need some data in the cloud. We are not talking about Synapse. If someone says data and it's Microsoft Scope, the next word is usually Synapse. Now we are talking about applications where Synapse isn't the go-to tool. Cosmos DB and SQL database, Azure SQL, are the two regular tools. Cosmos DB, to how many of you is this tool familiar? Raise your hand if you worked with it. Like half. It's this multi-model database that has documents and key value and other ways of storing stuff, and you can scale it globally infinitely as long as you have the dough to pay Mr. Mark Brown here. He will later come here on stage and say, yes, all the money comes to my bank account. Basically with those words, I think. Cosmos DB, let's not talk about SQL. We know SQL, it's a great relational database. Cosmos DB is a tool that's been used wrong for a number of years, and it hasn't been made easier by the Cosmos DB team who's designed it wrong. And now they are fixing these things. Nice, Mark. What Cosmos DB is, why is it so great? It is the only database you can use for a month and use it to serve 1 billion requests in a month, and it will cost you 20 euros. You cannot serve 1 billion requests in a month from SQL for 20 euros. That's not possible. With Cosmos DB, you can. That's possible. I think most of the teams here who have worked with Cosmos DB, the experience has been the opposite. It's been the opposite. There's a little bit less calls than 1 billion a month, but the cost hasn't been 20 euros a month. It's been like 2,000 or 3,000 a month. That's the common experience with Cosmos DB, and it's a thing that Cosmos DB team clearly is looking at closely. If you look at the build releases now, what's coming, what's in preview in Cosmos DB, there's these burst mechanisms and there's this repartitioning capability and all kinds of tools that can help you manage the cost of Cosmos DB. And today, the fact is, if you design Cosmos DB correctly, it can be efficient and it can be cost effective. And I think Mark will be speaking about that directly. So that is an interesting tool that can scale quite high. And then we get to the binary storages, the even cheaper, even dumber storages where you want to put a lot of your stuff. There's data lake storage and there's Azure storage, and they're the same tool, but data lake storage has one toggle on hierarchical namespaces on Azure storage. So the pricing for both of these storages is the same. They have some different access control mechanisms. Azure Data Lake Storage has a real folder structure, while Azure Storage only has key value keys to find blobs, so you can't modify or work on multiple blobs with a single key. That would be the folder, so to say. With Data Lake, that's more robust mechanism. If they're the same price and Data Lake has more features, why would you ever use Azure Storage instead of Data Lake? The answer is that Data Lake will generate more data. For every file, JSON, whatever you push there, Data Lake will generate a metadata file that will contain the configuration of the folders and access control, all that stuff. So if you have a storage for 1 trillion small files, Azure Storage will be a lot cheaper. But if you look at the Azure pricing calculator and you look at okay, these are the same price per terabyte, it will feel like there's no difference, but there is. What's interesting is that with Azure Storage, I said that they're done because they're key value. Azure Storage received a while ago this capability of indexing. When you build, I don't know if you were aware of this, I know this last week that not many people are. If you put data into Azure Storage, you can configure some of the attributes in your payload to be a basis for an index. So if you are just searching for certain data with certain attribute like city or, I don't know, surname or something, you can have that, in addition to having it in the key, you can have it in the index of Azure Storage. And then the storage looks into your payload and indexes your files with that. So it's not as dumb. It's actually, in some cases, it's a pretty efficient replacement to SQL if you don't need a lot of joins and complex queries. Check out the indexing. Then we have the messaging. We need to balance load. We need robustness. We need reliability in our application. And for that to happen, our API, which gets requests from the clients, we don't want that API to crash. So when data comes in, we want to send messages to whatever eventing mechanism or service bus, and then Azure Functions or other serverless processors that cost per time, when they run, they do the processing, for example, generating a report. Azure DevOps for CI/CD, IAC, and stuff like that. Key Vault for secrets, and Active Directory. Active Directory for of course, some kind of authentication. Of course, you can have Okta or Auth0 or this kind of stuff, but you will have Azure AD anyway, and for your internal employees, that will be, free of charge. Although now, of course, it's Microsoft Entra, which is Azure AD, and then it has this permissions management that was Cloud Knox that Microsoft purchased a year ago, and some verified ID thing. So Microsoft, they just created a new product that contains a bunch of identity products, but nothing changed in Azure AD in that sense. Cool. Now, we've spent some time walking through some pieces that we will use. You're not familiar with those. I don't have to speak about those as much when I'm drawing. And now we will have a long, uncomfortable silence until someone shows an idea for an application. Maybe you're working on an application. Maybe you have to design an application. Maybe just shout what's the need and I'll do the design.
There's a flaw in your plan. Finnish people like long, uncomfortable silences.
Oh, it's not a flaw. I don't see any hands up. So the thing, to presenters, it's 7 seconds when you ask a question. The average global is 7 seconds you have to wait. Pasi, you are ahead of time. What's your idea for an application?
I've been doing some market research, and it seems that there's a global growth mean, and what is users would like to know kind of where can they find the nearest mean to growth.
Okay.
And if we go a little bit further, we could maybe sell the data we get, so we can see where the largest needs for these models are. And
is Alko your client? It starts to sound like Alko is your client. Okay.
And people can make orders by putting a PDF into an email attachment.
By putting a PDF into an email attachment. Thank you, Glenn. I will love designing that feature. Shut up, FileStream SQL, man.
We need online training
Oh, but this is technical talk. I don't. That's not. The training isn't my cup of. That's not my cup of tea.
I can learn more techniques on drinking.
Oh yeah. So videos like self-help videos on how to guzzle faster. Okay. So there's one idea about the global reach of a beverage. Do we have another idea, sir?
Great, with full of ice cream, and it notices which ones are going empty, and it sends request to order API, the order more ice cream, and it sends you a Teams message to approve the order.
There's too much Office 365 in that. Teams request, my God. Thank you, sir. You unknown person who eats a lot of ice cream from the fridge at the office. I want to, sir.
A camera up for Jenga, which calculates the best block to take out of the tower.
Oh, God damn, that's... Camera for Jenga calculates the best block to take out of the tower. That's an interesting one. Can we get one more? Sir?
Maybe involving that, like...
Involving the mean to idea, you say. Yeah.
Like, where is the nearest place, where is the free place in terrace, and they're serving certain things, and how to get there?
Okay. So, I heard one idea about self-fulfilling fridge, one camera thing that would be interesting. Then we had this drinking thing. If we expand the drinking thing into a product thing, that we get some products, maybe we can get with that. First, I need the business framework. Sir there who gave this idea, is this application created by the business who produces these beverages and edible products? And for what purpose? Is it for them to follow, okay, for example, companies like Puuilo and Motonet. Do you know what's the problem? The problem is, where do I put this store? Where do I put this store? They are, in Finland, there are places where people buy grills and shit, okay? Where do I put this store so that I know that people nearby come and buy grills from us? That's what Puuilo and all of these companies think about. What's the most effective location for a store? So this example of this application idea of following where people consume the product that this company needs, that's actually very meaningful to a lot of companies. So if I just keep on rolling with this, we have this business need by a director or a manager who says, we are doing this product. And we see it going and people are buying it, but where are they buying it and where are they consuming it? And should we get it more accessible to people? That would boost our sales, right? People would know that it's nearby and it's, readily available at all times during the night and day and morning, like Mintu enjoyers like to have. So let's start designing that kind of a thing. No, not the takeaways. Okay, so here we have my favorite program, Draw.io. No, it's not. Why? Oh yeah, there's what will we design today? Let's take that out. And then we open the Draw.io. Here, we will draw things. We have plenty of time. At the bottom, we have data sources. Up top, we have apps and consumers. In the middle, we have Azure stuff. Go Azure. So, we have the business need. Like Magnus said, you need to always know what's the core, what kind of return on investment the company wants for this application. And they want to know where is this product consumed. Okay. Now, that sounds like a reporting thing, right? Decision makers want to see a report. What is the local or postcode where these things are consumed. So let's not stay at that level. Let's make it a social thing. Okay? So you buy a product, Rick buys a product, and some other person in this room also buys this product, and they want to have a chat about the product, and they want to find each other. So let's make it a mobile app. There's a mobile icon. It's not big enough. I'm sorry, all of the icons will need to be, I'll just constrain. There we go. And this is the mobile for product usage thingy. That's the best name for an app ever. Mobile for product usage thingy. And then we already know, because we wanted the, what's report? There's no Power BI icon in this Draw.io directly. So let's have this kind of thing here. And height, 69 is wrong, 50 is good, so that this diagram is ready for the client, right? Reporting about good locations for directors. Cool. Now we have here the two things that our users need to see, two different user roles, right? The next thing I want to understand, if this is the impact we want to create in the users, the next thing I want to understand is the ecosystem. The technical ecosystem. What are the systems around our application, which is greenfield, this never existed? What are the systems we need to communicate with? So I'm thinking, since we are talking about, what are we talking about? We are talking about products. So there's going to be some kind of a PDM or PLM, that's product data management or product lifecycle management, right? Then we are going to have customers, because customers buy. But of course, if customers are resellers, we produce this thing, and then it's a reseller who sells it. Still, it will be some kind of a customer who's bought our things. We're going to have CRM as a system. And then what else? We're going to have MDM for some relations, maybe, I don't know, master data management. And then we are going to have like images about the products and stuff. Oh, SAP, yeah, let's just add, like, let's cover this MDM by SAP, so we are very, very much on the road to chocolate future. So now here's our ecosystem. Where I begin, I started coding at Silja Line Tallink, Silja 2001 or something, with .NET 101 or something, 2002 maybe. And I learned to look up the data first. I know that in today's world, there are people who look up the user experience first, and the cases that people do, and that makes sense. But it's not how I do things. I look at the data, and I'm like, okay, what kind of data we get? So let's think about the data we are getting. We are getting products, and we are getting information who bought the products, the reseller, and then we are enriching that with the data we get from the mobile. When Rick bought it and he's like, hey, I'm here drinking this product that you produced. So we know that there are relations. So the first thing that comes to mind is a SQL server for customers and products kind of thingy. And the other option would be Cosmos. Mark is here. The other option would be Cosmos that we spoke of, where we wouldn't have relations, we wouldn't do joins, we would instead have a document that would contain all of the relevant attributes. Let's, for example, if we have resellers who sell our products, let's have resellers and products in the SQL, they have relation. And then we can do the Cosmos for the mobile app. Let's say this mobile app is global. I don't know if it is, but let's have it this way. And mobile app users and geospatial data. Nice, geospatial data. Cool. So, yes, sir.
So if you're tracking relationships between the people who are consuming and each other and the retailers, could that not be a graph?
That could be a graph. That could be a graph very well. And then Cosmos DB would, of course, be a good tool for that too. That's a good point. But I won't go anywhere with that point. It's an excellent point. where I wanted to go with the geospatial is that if we are having a map where we can see people, I don't know which one is the right logo for Azure Maps. And I don't know if you're familiar with Azure Maps. How many of you have done some kind of mapping features with geospatial data? How many of have you worked with front end that has some kind of, cool, there are some hands up, not too many. My layman's understanding is, from our perspective, if we were creating an application in the cloud, and the idea was like this that we have, where we want to see where people are working with our products, we have approximately 2 rough choices. The other one is to have open source geospatial server, like Geo server, which is a product, you can check it out, or map server. You can have Geo server or map server in a Docker container from the web page, and then you can push that Docker container to run on Azure, on any of the multiple Azure resources that can run Docker containers. And then you can have your front end make calls into GeoServer or map server running on Docker, and on your front end you would have open layers or leaflet, which are these JavaScript libraries that are used to show the map. And this is one way. The other way is to have Azure Maps, which sounds like easier already. Oh, Azure Maps, it just does everything for me. So of course it doesn't do everything for you, and it's invoiced very differently, but it's a managed service. So you don't have to care about updating your Docker, and you don't need to have a container registry for your GeoServer installation. So there are things. And what's nice is that I was actually thinking about Azure Maps, and I ran into this samples.azuremaps.com. And if you go to this site, if you're not familiar with Azure Maps, it's just geeky enough to be very interesting to see all kinds of stuff that you can do with Azure Maps. There's like a bunch of, and it understands most of the standards. So if you're working with maps, sir.
Yeah, I was just wondering why you need GeoServer. Instead, if you are having points, you have custom API, you can use, for example, Postgre and PostGIS.
Yes.
Without any additional services.
Very good question. Why would we need GeoServer? Because we could use PostgreSQL for Azure, which is a managed SQL, and then have PostGIS library or addition or enhancement on PostgreSQL. Also, you could use Cosmos DB because Cosmos DB understands geospatial like data, doesn't it? Yeah. So there are multiple databases. If you just want to work with points, GPS coordinates, and you want to do some kind of distance or whatever functions you want, you can just use the database. So don't take the GeoServer or Azure Maps for the fun of it. But of course, if you see that the need would be such that you at some point maybe draw some markers and do some vectors on the map and all kinds of stuff like that, then you might go to a more robust serving. Very good point. Don't go too far, but since this is make-believe, I'm going to go very far. Just do all of these things. So let's go with Azure Maps. And that's an API and a data storage, so let's have it there in the between. We have plenty of time. What else data we had? We have pictures of the products, right? We might have social elements where people send pictures to each other. So we can have data lake. Let's have that icon. And why data lake? I usually err on the side of data lake when there's a binary storage. And that's because if we look at the big picture of the larger organizations, if there's some data that comes to data lake, like for example, let's say the products and CRM produce customer data already into cloud. That data regularly as part of the data platform for the enterprise goes into data lake. So it might already be there. Our application wouldn't even need to create an integration if the data was in the cloud already. So I added data lake for this reason. If you don't need the better access control, you don't need the folder structure, and you are not looking at doing the Jenga application where you do data science to analyze the best location to put the block, and you don't therefore need some Spark engine to do the analysis like Databricks or Synapse or one of those tools that regularly get data from data lake, then of course they can get it from storage as well. Then this could easily be Azure storage as well. Let's go to integrations. Just go fast through the integrations. So we have Data Factory. We want to move data from locations, right? We have Data Factory with a 2 high element. Then we have Logic Apps. Logic Apps, not sure if this is the correct color. 2 pixels too high, can't stand that. And then we have Azure Functions. Azure Function. There we go. A bunch of icons. Now we are in the space of integration platform. Some companies, large companies, they provide this integration middle layer. Maybe they are, lucky enough to have Beanstalk in there to handle all of this trouble. But if you are going to cloud, and like in Rick's case, they were replacing Beanstalk with these components, then these would be the components that you would look at. So what's the difference between these components? Data Factory is an orchestrating tool. If you're a data engineer, you know Data Factory as the ETL tool for yourself. And with Data Factory, it's very easy to, for example, replicate a SQL from on-premises to cloud. So it's just configure. You don't need to code anything, and that's just nice. If you need to do some transformation or validation, from Data Factory, you can start processors, serverless processors, like Logic Apps or Azure Function, to do something and then get back to Data Factory pipeline. So it's this orchestrating tool. It's not a coder's tool per se, but it's something that more developers should look at in certain scenarios. Logic Apps are visually designed integration tools that are very familiar for ex-Beanstalk developers. That because Logic Apps don't need code either, and there's a mapper and you draw lines and you draw loops and stuff. And then there are functions that you just add your code and run your code in it. So if you look at it from left to right, the skill up of the person who is using those, the skill level rises. The issue with all integrations is that in this case, where, for example, when we have here multiple ways of connecting to different places. I want to do the other way. Do we have, oh yeah, this is for images, that. And then for SAP, we have Logic Apps have a ready adapter, so that's going to be cool and easy. And then this CRM is custom. I just said so. And this PDM is crappy. So we are doing that with Azure Function as well. So these guys do the calls. The difficulty with integration platforms is that if you have a lot of integrations, it's not these pieces that are difficult. It's not the end-to-end, the point-to-point integration. It's the monitoring. If you look at the companies you are working at, or you're looking at the companies that you are consulting at, they end up with 50 or 100 different pieces, like Logic Apps or Azure Functions. And when something happens, something doesn't work, it's like, okay, what's happening? You know, there's this whole spaghetti of thing. So the monitoring is actually in today's world, and that's something which is difficult to realize, since Beanstalk and MuleSoft and these other tools, they have the monitoring built in. Now in the cloud of today, when you go to cloud with your integration platform, you don't have the monitoring built in. You have a monitoring per service. So you can see if this specific Logic app is doing well or not. But if you have 200 of those, you just waste your life going through those 200, seeing what's up. So what you need for this monitoring story is Azure Monitor or Application Insights. Application Insights, which feeds into Azure Monitor. So you have this, and then you just push from all of these components, you push data into your telemetry tool. that was referred to earlier in the talks. And then you create an Azure dashboard. And in that way, you try and find some kind of a, visualization at a glance. How are our integrations doing? Since there will be tens of those in any given company. Sir? Are durable functions a thing? Still the thing. Were they the thing at some point? They are a thing.
Yeah, that was the question. Are they still a thing?
Yeah, they are still a thing.
So then you make your function stable, and then you can leverage event sourcing.
Yeah.
So then you can make ETL 500 functions.
Yeah, so the consideration here by a fine gentleman was the possibility of making stateful Azure functions, and in that way build an ETL and data transfer pipeline with Azure functions. That does make sense. It is pretty developer point of view thingy, because if you go to an enterprise, large organization, and they have their data team, their view on ETL, so the data transfer, extract, transform, load, or extract, load, transform, ELT in the cloud nowadays, if you look at it academically. But still, the thing is that they try to stay away from Azure functions. So if we, to a company, we build purely Azure functions pipeline, it will be way out of scope of the know-how of the existing data team. Now, if there's no existing data team, and there's just developers, sure, you can have long-running transactions in a durable functions. But if they want to hire a data team in the future and they look for data engineers, those guys will be a lot more knowledgeable and understanding of using Data Factory as an orchestrator. So I wouldn't do that. In the first meeting, if someone told me, let's do this, I would be like, whoo! Let's pause a minute, see if it's meaningful, if it's right, and then let's do it if it turns out to be right. Hard, good question. Okay, so we have our integrations. We get stuff to different places, all kinds of stuff. Not sure if we want to put that there. Where is this going? Oh, this is going to SAP, nice. And where's the images? There's the images. See how beautiful this will be. If you can't invoice top dollar for this, I don't know what you can. Oh, nice, yeah. I did this in Kuopio, and the guy had an application idea. I don't remember if it was, I think it's Kuopio. And once we'd done this at the end of the session, he said, thank you, I'll call the customer. Okay, he had this idea about the forest app or something. So yeah, that was very friendly of him to give me a boost. Okay, so what's missing? Like, is it done now? We're missing APIs, right? We need to get the data to our application, so we need APIs. I said earlier that app service is a thing that I like to use for those APIs that are supposed to be on all the time. So I don't want them to be down at all. And just for the kicks, let's add, this must be an old icon, but it doesn't matter. Let's add API management here in the middle. And now when someone makes a request, it goes to API management and to APIs. How many of you have had discussions in your company or with the client about API management? Cool, half of you. API management is basically a tool where you can provision the concrete API implementation, then people call it, and then API management routes it out. And it makes sense if there are multiple vendors, multiple teams, because you can organize teams. The teams can generate their API keys from API management, so that's great. You can monitor the APIs. There's a single place where the company gets a catalog of APIs. Oh, these are the APIs we provide. Excellent. There's one place for this documentation, and it's live. So excellent reasons. But in scenarios, and I bet many of us have run into, API management is like, I think, 300 euros a month, the first sensible version or something. Some companies might not want API management. So what is the reason you would have API management if the client is small and they don't have multiple vendors, they don't have multiple APIs, but they have a business critical application like this product usage thingy that is part of the must-win battle for the leadership team. One reason from a developer perspective is the abstraction. So what is very nice with API management, since you can have it quite cheaply nowadays, that wasn't the case a few years ago, and I think many people started thinking API management is a big boy tool, but since you can get it with a sensible pricing today, it's quite cool when it abstracts the concrete implementation for the client. So if you notice that your API is crap, oh, I made an error, I was coding yesterday and I fell asleep and my API is there and it's not working, but it's mostly working and you don't want to have downtime for the client, you can just replace the concrete implementation and turn the API management to point to that, and you don't have to deploy a new version of the client because the client has been pointing to API management the whole time. That reason by itself is enough. When you make clear to the decision makers that, hey, this adds on the reliability of this business critical application. Just make sure that it's a business critical application or something like that. So that's cool. And then we'll have multiple APIs. We might have some endpoints that are reusable and so forth. And these guys make calls to and store stuff in the databases, right? Cool. And they can aggregate data, of course. Like, for example, if there's a feature like this guy, if there's a feature where Rick can send a picture of himself and there's information where he is, then we would, of course, need both of these databases because the other one has the binaries, right? Let's just have files and pics of Rick. Cool. So that's the data lake for it. We might need to provision another one. Rick really likes pictures, so. And then we might have that guy call Azure Maps. And now we had a question.
Yeah, so for the API management, also for enterprise, what would be interesting are products within API management and the developer portal.
Yeah, so developer portal is for the vendor management. So for the multiple teams that develop things, they can log in and then generate the keys and see some code samples, how we can call the APIs and everything. And products are very good if you have multiple APIs. And for example, some clients you let in or some callers you let in into the API. They make like, for example, 10,000 calls an hour, and some others might need 100 calls an hour or something. So with products, you can play around and limit and throttle and give quotas to API. So you don't have to code that feature into API. API management gives that to you. So there are plenty of things there that are quite meaningful in today's API-centric world because, it's all APIs. What are we missing? We are missing Azure AD that we'll have for our users. And since this is a consumer product, we might have Azure AD B2C that the mobile thing logs in for. Azure AD and Azure AD B2C, what's nice, we are talking about external identities. They share the limit of free users. I'm not sure if people are aware of that. So Azure AD can have 50,000 monthly active users for free. So if your client is using Azure AD, they can invite 50,000 people to Azure AD, and they all need to be active on a given month for it to, and then it will be still free. So if there's like 100,000 people invited, but they're not all active in the given month, it might still be free. But what's fun is that if the same company has Azure AD B2C, and they invite external identities there as well, Azure AD's external identities 50,000 quota limit has eaten in the budget of B2C's external identities. And that's not the clearest thing that's said in the docs, I don't think. It's very interesting that there are two different products. They work very, very differently. And usually my one sentence advice on Azure AD and building applications is, if the application is for a B2B customer, use Azure AD. Do not use Azure AD B2C. There are multiple reasons we can have a chat, but if it's for consumers, B2C gets better. What do we have? Reporting about good locations and directors. Cool. Let's have a data mart here. Data mart. So this guy collects data in a nice dimensions and facts or data lake or whatever format. So the Power BI reports or Tableau or whatever can get this data so that the directors can see where have we used this application. And how do we get that there? Well, let's add messaging. Let's go with Azure Service Bus, which is the go-to tool if you want first in, first out, dead lettering, all kinds of business requirements. So messaging, and maybe this API here sends a note to messaging, and then maybe this API collects or sends note of usage if it's a real time. So this API knows whenever someone consumes the product, okay? And it sends data to messaging to the pipeline about, hey, someone consumed one product, and this is the location. And then we have an Azure function that's listening to these messages, and then it gets the message, and then it stores and does some kind of merging, like per second aggregation. You know, if we get 100,000 messages in a second, we don't want to have 100,000 messages in the data mart that is being read by Power BI. We want to have a single message per second, for example. So we would have Azure function aggregating all of that. Or Stream Analytics, of course, which is a very nicely priced tool for that same thing. And then we would have that data in data mart done by messaging outside of the APIs or any of the core processes that are required for the working of this application, instead done by serverless components as needed, scaling, and the directors would get real-time dashboard. They always ask for real-time, but nobody does them because it's so very hard and costly, and I'm not joking, it really is. If someone asks for a real-time dashboard and it's supposed to come from Synapse or something, just say no. And if they want in the report, they want one number. You ask, so you want this whole sales report real time? And they're like, yeah. And then you're like, okay, if you could have one number that's real time, what would it be? It would be like inventory or price or something that's very hot. Then you would create another pipeline out of ETL with Azure function or something else that would just bring that one data to the report. And that would update real time. But otherwise, the report would be updated 3 times a day. There's hand up. Sir.
How would you go about in selecting between Service Bus and Event?
Good question. So the question was, how would I go about selecting between Event Grid and Service Bus? I would think about if the message has, if the event or message has a particular value in relation to other messages or events. So if we look at, they are both capable of at-once delivery, but the delivery isn't guaranteed order. So Service Bus delivers in order, and you can have filtering and topics. And in Event Grid, you can have these domains as well, where you can choose certain topics for certain consumers of Event Grid. But in general, events should be looked at. This happened, that happened, there happened something. It's a lightweight notification event somewhere. And Service Bus things are business process steps. There's a transaction, dingly-dongly-dung. That's the order. So if you have a temporal meaning, a timeline of multiple messages, go with Service Bus. And if you have events, go with Event Grid. Did someone have a question other than this? I have 4 minutes, so I guess our design is mostly here. I hope you have received a lot of value out of this talk. I have a bunch of takeaways. See, animations. Takeaways. Technical takeaways. There's only like 10 services we used, right? So people come, oh, there's 600 services in Azure. Don't listen to those people. There's like, there's less that are meaningful. Storage is hard to change. So when you think of the storage, it's very difficult to change later. So spend a little bit time on the data. And for the data, what we didn't have time, we didn't really define use cases. For the data, we would need to know if we use Azure Maps and we have a search, Rick wants to search for people who are mega consumers of this product. We need to have some kind of data storage that lets us query the mega consumers fast for the clients, right? And what's a good tool for that kind of thing? Well, maybe you aggregate some data, you do a nightly snapshot or whatever. So think about the storage with the use cases. Messaging is resiliency. See, I added multiple memes because they're also funny. Messaging is resiliency. So offload anything you can from the core processes to serverless. Identity is global. Azure AD, we all hate the process in the company where we work that is related to Azure AD. Azure AD as a product is pretty nifty. It's not down a lot. It's fast. It obeys standards like OpenID Connect. Like it's very cheap. It's a good product. It's just that it's so different to other products that, it's still companies are thinking, how do we do this? Production readiness. When you've done this and you start coding, remember to tell the client, hey, we need security. Magnus said it's not that apparent. Business expects this to be secure. You need to say, let's create it securely. And in every sprint, you can add one story about security. Add stuff about monitoring, and then have a feature freeze at the end. Business-wise, why? Where's the return on investment? Feedback loop is key. Create something often so that someone says an opinion about that often. It doesn't matter if it's wrong what we do. It matters if we don't know it's wrong. It's fine to do wrong things. It's not fine to be silent about what we do, because in that way the client can say something about, hey, how you guys are doing. And teamwork is success. None of us would build even this small application by ourselves in a sensible amount of time and with no stress. With teamwork, maybe there's some stress, but at least it's balanced load, right? Thank you, guys. One minute for questions, and we are done. Thank you. It's now snack time. Oh, Rick has a question. So, is it a long one? Please.
I hope not. So, in lots of examples in that architecture, you had several different choices of service. Any of which would have done the job, but some might fit better than others. So, what tips can you give people for how they choose?
Yeah, so the question is, since there are multiple overlapping services in Azure, how do you choose the correct one from the get-go? Tip number one is experience, so fail once, and then the next project will be better. Tip number two is convince the decision makers to let you do some kind of MVP or proof of concept. Tip number three is understand the use cases, because all we do is we decide the services on how the users use them. And if you think of a large-scale, long-term project that most of you have done, I bet, the scope changes in the midway. So it's in production, and there's a new need for business, and they're like, hey, let's do a feature like this. And you're like, our data storage doesn't support that feature. And then you either cram it into the existing data storage or set up a new data storage with the repositories and everything, complexifying the design. And either way you go, after a few years, you'll be like, hey, could we refactor? And the business is like, oh, we would need more features instead of refactoring. So yeah, not very good take on your question. I don't have any good answers. There are these decision trees in Microsoft Docs. And Docs help. But maybe, I don't like to say call a consultant. I don't really want to say that. But maybe ask a friend who's done a project with the technology you are thinking about. That's the way to go. Thank you, Rick. And now it's half an hour of snacky time, and the rest of the questions can come to me. Cheers.